today we'll continue working with trig identities, but today we're going to simplify expressions. In the previous lesson we had an equation and they wanted us to find sine, and so we did it by substituting, and we would substitute for cosecant to get 1 over sine is 1/2, and then we could see that sine, let me change this, make that a 2, and then we could see that sine is going to be 1/2. So the difference today is we won't have an equation, we just have an expression, and we want to make this expression smaller. And here are some strategies that we might try. Again, when we're dealing with trig identities, sometimes you just try something to see if it works, and if it doesn't, you try something else. So we can rewrite all the trig functions as sine or cosine. If we're dealing with rational expressions, we can have make sure we get a common denominator, and sometimes we can create a Pythagorean identity. Okay, so again, let's make a list of the possibilities. And we see a cosecant, so we'll look through the list of identities, and we see that one. We have a secant, so let's put the secant in there, and we have that one. We have a cotangent, so we can write cotangent is cosine over sine. We can also use cotangent is 1 over tangent. So here are some possibilities, and we can just try them, see if any of them work to simplify this. So let's try cosecant is 1 over sine. Secant is 1 over cosine. And cotangent is cosine over sine. So here we have sine, cosine in the denominator. And we can get a common denominator. So let's multiply by cosine over cosine. So now we have 1 minus cosine squared and now we have cosine squared. So let's look at the Pythagorean identities. Sine squared plus cosine squared equals 1. Can we make this appear from here? And we can by subtracting the cosine. We want 1 minus cosine, so let's write it as 1 minus cosine. We can replace it with sine squared, so this is sine squared. And we can cancel one of the signs, so we'll be left with sine on top, cosine on the bottom, and that is tangent. secant x minus tan x times sine x. Make a list of possible identities and then try to simplify. Pause the video and try that one. So if we see secant, we want to consider that. Tangent, and sine, probably going to leave sine the way it is, but we could consider that one. And it looks like in the previous problem we just changed everything into sines and cosines, so why don't we try that in this problem? Secant is 1 over cosine. Tangent, if I use this, it's going to throw it off, so let's use tangent is going to be sine over cosine. And we already have sine there. Sine is just sine over 1. So now we have 1 minus sine squared over cosine. We see a square, so let's look up the Pythagorean identity. Sine squared plus cosine squared equals 1. Can we make 1 minus sine squared up here out of this? We could just subtract sine squared, so cosine squared is 1 minus sine squared. And this can be replaced by cosine squared, and now we have, we can reduce. We have cosine on top, cosine on the bottom, and we're left with just cosine. Or I'll show the work. And we're just left with cosine. So we have sine squared. Since it's squared, let's go ahead and consider using a Pythagorean identity. Cosine, we could consider cosine is 1 over secant. Sine is 1 over cosecant. Here we have sine with the cofunction identity, and we know that that equals cosine. And let's substitute. Well, right away, if these are x's and there's a pi over 2, let's try to turn this into an x. So sine pi over 2 minus x is just going to be cosine. Sine squared cosine minus cosine. If we start changing this, it could get more complicated, but here we have a common factor, and it can come out, and we can factor out a cosine, and what's left is sine squared minus 1. If we go cosine times this, we get that. Cosine times 1, we get cosine. So we know this factorization is correct. Sine squared minus 1, can we make this appear with this? And it would just be, we need to have a minus 1, and then we'd go minus cosine squared. I need to subtract cosine squared and subtract 1. So now everywhere we see this, we can put that, and that goes right there. All right, try that one. Pause the video. So we have cosecant of pi over 2 minus x. That's a cofunction we can use a cofunction identity. Cosecant is related to secant. Tangent squared, we know tan squared plus 1 is secant squared. We also know that tangent is sine over cosine, and tangent is 1 over cotangent. Secant is 1 over cosine. So let's see if these, if any of these are going to help us. Definitely want to get rid of that, pi over 2, so we can replace it with secant. And here, let's not substitute anything because we have a common factor. Secant can come out. -1 minus tan x, tan squared. Oh, that's not what this looks like. So why don't we take a negative out in front, put a negative. And now we have 1 plus tan squared, that's secant squared. Let's simplify this. Looking back at the beginning, we had rewrite with sine and cosine. We've done that. We've used a common denominator. And so here we're also going to create a common denominator. And in the process, we're going to create a Pythagorean identity with this. All right, we'll make a list. We have, they're all sines and cosines, but just be aware that sine squared plus cosine squared equals 1. That's going to be showing up. We need a common denominator, so we need to multiply this side by 1 minus sine x, and we need to multiply this side by cosine. When you multiply this, 1 times 1, we get a 1. This would be a sine minus sine plus sine minus sine. That'll cancel, and then we get minus sine squared. Let's leave this. And we'll have sine cosine squared minus all of that. All right, so I just did cosine times cosine. Here we have the common denominator. I only wrote it once. And sine minus sine cancels. Then we're going to go minus 1 and plus . Let's do this. Instead of, when I'm looking at this, there's nothing I can do because of that 1. So this is what happens when you are working with trig identities. Sometimes you take a step that you need to change. So we're going to, instead of doing that, let's see this 1 minus sine squared, and here's our original identity. Cosine squared is 1 minus sine squared. So this turns into cosine squared because it's 1 minus sine squared. The whole thing in here is cosine squared. One minus sine squared is cosine squared. We have the subtraction. And now we can factor out a cosine squared. And we have a few things happening here. Sine minus 1, 1 minus sine. They're in the wrong order, so we just have to change the order of one of them. We also have cosine canceling with one of those cosines, so we have a cosine left in the numerator. Let's put a negative out there, and we'll have 1 minus sine. Negative 1, and negative times negative is a positive. 1 minus sine. So we get negative cosine. Okay, just a hint before you get started. Go ahead and find the common denominator and see what happens. We have there are already sines and cosines, so just keep this in mind that we might need a Pythagorean identity, and we're going to have we need a common denominator, so we have to multiply this by 1 plus sine. We need to multiply this by cosine. That'll be cosine squared. Cosine, just leave that, don't distribute it. Now we have to distribute all of this. It's going to be 1 times 1, sine plus sine, and sine squared. Now we're going to combine all this with one denominator, and we have cosine squared plus sine squared. All right, so I just copied the denominator once. Cosine squared plus sine squared, I saw that that's going to be a Pythagorean identity, so I grouped those together. And then I just copied the 1 and 2x. This is equal to 1. So now we have 1 plus 1 plus 2 sine and that's going to be 2 plus 2 . Factor out a 2. Cancel. And we get 2 over cosine. We can also write 2 secant. So 2 over cosine is the same as 2 secant. And here is where we can use this strategy. We just got done using the common denominator, and we can in this next problem, we don't have two expressions added together. We don't need a common denominator, but we can create a Pythagorean identity. So we're looking at this, we see something squared, so keep in mind that we might need sine squared plus cosine squared equals 1. And then if we multiply this by 1 plus sine in the numerator and denominator, this is going to create a Pythagorean identity. So 1 times 1, sine, that'll be a negative sign and a positive sign. So we have a negative sign x, positive sign, and then minus sine squared. So this equals 0, and we have 1 minus sine squared. One minus sine squared. And maybe that's a Pythagorean identity. So let's look, can we make this? Can this appear in this? If we just subtract sine, 1 minus sine squared. 1 minus sine squared is cosine squared. So now this can be cosine squared. One minus sine squared is cosine squared. Now we have that, and we can cancel. So we're down to 1 plus sine. Okay, try this one and go ahead and create a Pythagorean identity. Pause the video. Secant and tangent. If we're considering some of the possibilities, we have 1 plus tan squared equals secant squared. And we're going to try to make something like this appear in the denominator. Secant squared minus tan squared. 1 equals secant squared minus tan squared. And so that could give us an idea. If we can make this appear, then we can replace it with a 1. If we want there to be subtraction, then we should just multiply this by secant minus tangent. And that'll be secant squared. That'll be tan secant minus tan secant, so that's canceling, you get 0. And then we have minus tan squared. Secant squared minus tan squared is 1. Don't forget the parentheses. So we have 4 secant minus tangent, and that equals 1. So we just have it over 1. And that's it for today.